All right, this is Module 1. Module 1 covers parts of Chapter 1, 5, 8, and 14. In the weekly folder for this module, you're going to see exactly the areas of each chapter that you should focus on, and this is also on the study guide that you will complete this week. So Learning Objective 1, describe the underlying conflicts using the environmental problems we see today. So what I'm going to do is just kind of introduce really the crux of the issue in regards to environmental science, the interdisciplinary nature of environmental science, and then dig into a little bit of information about biodiversity and economics. Okay, so here we go. All right, so environmental science obviously contains the environment, and that's all the things that you see around yourself. So outside of our family room here, we have a window, so I will frequently be looking outside. But I can see the maples are blooming and the leaves are starting to come out, and the oak leaves are a little bit delayed, but they'll be coming out soon. I can also see that we have a huge diversity of birds in our backyard right now because of spring migration. You can also take a look at, the weather this time of year. May can be iffy. We've had some snow this May 2020, but sometimes it's warmer and drier. But we know that day length is getting longer. So when we think about the environment, we're thinking about the living things, whether that's birds, fungi, how about earthworms, but also trees, as well as this non-living part of the environment we call the abiotic environment. So that's temperature, moisture, latitude, altitude, solar radiation, soil quality, so meaning what nutrients are in that soil. So those are all the non-living parts of the environment. So when we think about the environment, we need to not just think about that benefits us, but it's all that working around us that makes the earth a fully functional, holistic, hopefully healthy earth. So what does environmental science do? It addresses the study of the natural world. So you may decide, I really love this class and I want to go on and be an environmental scientist, and so you might do our environmental science program at SUNY CCC, and so you might study the influence of acid rain on fish life in ponds in the Adirondacks and how this affects birds. So we see that environmental science is very complicated because we know that one aspect of the environment often is connected to many other aspects. And so I'm hoping what you get out of the course is knowing some more of that information. So having some evidence or having some stories and having some examples that will help you understand that. So we know that we're completely dependent on the environment. We don't live in bubbles yet. We don't live in microcosms, if you will, outside of the earth. We know that we're completely impacted by our interactions with the environment. For example, I was taking a look at our electricity bill for April, and I'm seeing that we basically had a higher than normal natural gas bill. And April was very cold. In fact, we don't always build fires in our fireplace. It's more of a, oh, let's do that. It kind of sounds fun. Or during the holidays and you're hanging around, you want to have a fire. We're not using that to heat our home. We're too lazy for that. Okay, so what I wanted to say is that we had more fires in April, we had cooler temperatures in April, and therefore we're going to be running our heater more often to keep it warmer. So how are we dependent on the earth? Well, when we get a cooler than average April, then we might be using our heater more often, and having to do that, then we're having to pay for that natural gas. If you heated your home through wood, you might find that you ran out early this year because you didn't buy enough wood to get through. So absolutely, the environment is going to impact us, and we impact the environment. We are seeing right now air pollution is declining. Certain kinds of air pollution hang around for short periods of time. So you're thinking days to weeks. The gas carbon dioxide doesn't disappear that quickly. So it's usually on the order of decades to hundreds of years for that to actually change just by stopping something. But what we're seeing is basically running our cars and our buses and airplanes, that we are emitting less of those nitrogen oxides and sulfur dioxides into the atmosphere. So when humans change our habits, and stay at home more, then we are using less fossil fuels to run our cars and move everywhere around the earth, and therefore we see that that pollution goes down. So we are definitely interconnected with the earth, although some people feel really disconnected. Our course focuses a lot on sustainability. So thinking about meeting the needs of the present without compromising the needs of the future. So thinking mindfully, how can we progress through our daily activities? How can we make better decisions when we're purchasing cars and taking a look at miles per gallon, or in the future, thinking about where you'd like to settle down? Are you going to live in a city where you're have a smaller ecological footprint because you're living in an apartment building? Or are you going to have a really large house out in the country? So we're hoping that throughout the course that you get a feeling for what is sustainability. How can we not just say, okay, humans, let's go back to living very different lifestyles than we have for the past 1,000 years, and let's just go back and kind of live more nomadic lives, and that's not likely. So we want to think about how can we live more sustainably. All right, so the module gets to the crux of why do we have the environmental problems that we see today, and so we have to think about human population. So we're at about 7.6 billion people on the planet. There are tickers or clocks that you can look at online that basically uses some estimates for births and deaths, and take a look at basically there are more births per second than there are deaths, and so therefore our human population is increasing. So 7.6 billion people on the planet. If you take a look at the figure down here in the lower right-hand corner, you're going to see just what has happened over time. So if you take a look at the y-axis, it has human population in billions. So take a look. Here's 1 billion people on the planet. That occurred around 1800, okay? It is now 2020. So in 220 years, we have gone from 1 billion people to 7.6 billion people. There was a trend for the new billion people to take less time to populate the planet than the last billion people, meaning that we were just accelerating, or what we call exponentially increasing the human population. We're now seeing that it's taking a little bit longer to reach the next billion, so we are moving in the right direction, which is a good thing. But basically what we know happened during this time is the Industrial Revolution. Industrial Revolution brought with it or the beginning of all the conveniences that we have now. Automobiles. We can heat our homes with natural gas or electricity. We can get antibiotics and vaccines. So we have the Industrial Revolution to thank for our modern society. Because of the Industrial Revolution, along came with that better medicine, better sanitation, but not always birth control. So as we dive into the course, we'll talk about something called the demographic transition. We're talking about that basically describes a country's transition going from pre-industrialization through a transitional period to post-industrialization. And so what tends to happen as a country, we might call that a developing country, many years ago, decade or more, we used to call that third world countries. And there's also second world countries. But as developing countries are making their way through the various stages of the demographic transition, and they receive modernity, in there comes this thing that happens as you get modern medicine and sanitation. You have a decrease in deaths, and so birth rate stays high until there's a couple things: realization that not all your children, most of your children will survive to adulthood, and so it takes that pressure off of having more children. But also living in a more industrialized society, you don't really have the need to have so many children, for example, if you're a farmer and working the land. And then on top of that, birth control comes with that modernity, if you will, with modern medicine, But in many countries where women's rights are limited, then that is compromised. So there's some very tricky things that happen in countries for there to be an actual decrease in birth rate. Okay, so just a little flavor for what's going to come later. So here we go. Moving on, there's this little nifty thing, maybe you've seen it before, it's called the ecological footprint. Basically, it describes all the resources, or what the slide says, the area of biologically productive land and water to provide you with all the resources that you need every day, as well as disposing or recycling any waste that you create. Wouldn't it be incredible if we actually could measure all of our direct and indirect wastes? If we could actually know when we bought that bell pepper at the grocery store, how many resources went into that pepper, if it came from a hydroponic greenhouse in Canada compared to an organic green pepper that maybe came from Holland. Wouldn't it be great to know what is the actual amount of resources that went into this pepper that I have? Long and short of it, we're going to start on our summer season soon. And with that, we get a lot of locally available produce. So yeah, you buy a green pepper that was actually grown in the Finger Lakes, man, you just decreased your food ecological footprint to a tiny little speck. If you grew it yourself, that's pretty much carbon neutral, or even reverse so, But let's think about everything that we buy, everything that we consume, whether that's stuff, clothing, food, your favorite beverages, or even the waste products. That food and beverage comes in containers. Maybe you're done with a garment of yours, and where does that go? So we need to be thinking about what comes in our lives and what goes out. We have a project in this class. I had to make it a 21-day commitment. I really like to do it for 32 days because it takes about 32 days to 40 days to truly change your behavior. But since our class is shortened just in the 5 weeks, by week 2, you're getting a commitment to the environment that you can stick to for 21 days. One commitment, okay? It could be trying to eat local fruits and vegetables, okay? So that means only from your yard, or only from a farmer's market, only from farmers. You might try that. Some people try with something simpler. They stop buying bottled water. Instead, they just use water from the tap. If the water from the tap doesn't taste very good, then put a filter on that tap. You can buy a filter for about $30 that you can use with your tap. So I'm going to ask you all to make a commitment. And in that commitment activity, there's the opportunity to go and actually do an ecological footprint quiz. And when you add details to that, you can start to really see what's driving up your ecological footprint. So I think that you'll like that in this class. So anyway, moving on. What they're telling us is most of us, when we take an ecological footprint, we ourselves, if everyone lived like you and me, we would be overshooting what we call the biocapacity of the earth. That's basically what you can imagine is the carrying capacity of the earth. If you've learned about that in the past, that's kind of the stable population that can be supported by the environment. So you may look at something like deer or black bear or blue-winged warblers or whatever. But in this case, we're looking at humans. And so most of us have an ecological footprint that's well over one Earth, meaning if everyone lived like you and me, then we'd need maybe 1.5 Earths, or some of you might need 4 Earths or 5 Earths if everyone lived like you. So we can see footprints in the past were much smaller than they are today. So this is certainly at the crux of why we have the environmental problems that we have today. Think about all the things that you can just go out and get. Whatever you want. Amazon. Like, I got it. It's coming in the mail, In the 1960s, yeah, that wasn't the case. Okay, I'm going to give away my age. I was born in 1970. I remember Kentucky Fried Chicken was like a Thursday night thing at my house. We rarely ate fast food, and we rarely went out to eat. We were a blended family, and there was 4 of us, 4 children, and we just couldn't afford that. In fact, my parents went down to a local farm retail shop, and busted open bags of beans and rice, and basically we, you know, had to eat very sustainably. My mom also made a lot of tuna casserole, but it was cheap and it filled us up. Nowadays, any given day, 3 times a day, you can eat fast food. In fact, every single one of our grocery stores and gas stations has food on demand. So you absolutely don't ever have to have food in your house, figure out how to cook, do your own dishes, look up menus, recipes. So certainly our modern day conveniences, our throwaway society, and our obsession with buying new has got us in this predicament. Okay, so when we take a look at environmental science, the field is what we call interdisciplinary. So it's not just made up of biologists or social scientists. In fact, when you take a look at this sort of pie graph, if you will, and all it is showing us all the different disciplines that are involved in helping make decisions about the environment. So you're going to see that you've got your sciences kind of on the right-hand side, from ecology, chemistry. How about atmospheric science, geology? And then on the left-hand side of the graph, you see some engineering, which is an applied science, but you also see humanities like ethics, social sciences like economics and political science, history, anthropology, archaeology, and geography. So when we think about the environment, we're not just taking a look at right here, right now. So if you were to research acid rain pollution in the ponds and lakes of the Adirondacks, one of the things that you might get into is the history of those lakes. Many of the lakes in the Adirondacks have been man-made. So you might go back and take a look at historical references to how they were built. You may take a look at maps and geography, how those have changed over time. You certainly might get into some geology. So taking a look at how weather patterns have changed, even erosion over time, just to even take a look at the stuff that's draining into those lakes. And certainly you can get into atmospheric science because you're thinking about acid rain. Acid rain comes from nitrogen and sulfur dioxides, and those travel with air currents and usually move vast distances, and takes maybe up to a week for it to fall, 7 to 10 days. So most of the acid rain that we've seen in the Adirondacks has originated from Ohio. You should know that it's way better than it was in the 1980s and early 90s. So that is really good news. So you see that environmental science isn't just one discipline. You could actually use a lot of different examples. You could think about hydraulic fracturing. About 10 years ago, there's a big stir about bringing hydrofracking to New York, which it has not been brought to New York. The process itself, the byproducts of the process have made it into New York. So I'm not going to talk about that right now. But the promise of hydrofracking brought with it the idea that we were going to increase jobs, so it would help the local economy. Certainly engineering, because there was new practices, including cemented, completely cemented, what they call drill wells. But also thinking about, well, where do you get the water to frack the well? Where do you get the chemicals to frack the well? So now you're getting into chemistry. And then what do you have, for example, in Pennsylvania, where they've had migration of those hydrofracking chemicals, as well as radioactive material from the rocks, which is not uncommon. But once you bust open rocks that are over a mile deep in the earth, and you're bringing the natural gas plus all the stuff that you use to frack that rock, as well as all the other stuff that was stirred up, then you're going to bring up radioactive material. So then we start to see, okay, how do some decisions like that impact, how about human health? How about animal, plants, fungi, fish, bacteria, and earthworms that live there? So you can see that environmental science gets very involved. It gets very complicated. All right, we can compare ecological footprints of various countries, and it's not going to take you long to see that those countries with the most wealth, those countries with the most resources, those countries that are developed are going to have larger ecological footprints than those that are less developed or those that have, for example, more poverty and less wealth. So you can take a look. You've got the United States, Canada, France, being the heavier Sasquatch footprints than countries like Haiti, in India, and Rwanda. So that's something to think about as we are moving through the course, is discrepancies really between individuals on the planet. Not all of us are created the same in that we have equal opportunities and access to resources. So getting back to thinking about the course. So the course is called Introduction to Sustainability, Environmental Science and Sustainability. So we want to think about solutions. This isn't necessarily a doom and gloom type of course. Environmental science really has changed over the years, kind of moving away from the doom and gloom and scary stuff to thinking about solutions. I'm a real firm believer in taking a look at technology and taking a look at the ideas of our millennials and Gen Zs and piecing that together and really bursting out of paradigms, really stoic, hardcore box thinking, and thinking of some real solutions. Okay, I'm a Gen Xer, so we're pretty good to have around because we're, in general, the generation is just rebellious enough to not just assume that status quo is okay. So we're seeing that as our younger generations mature and get into leadership roles, get into engineering, technology, even writing roles, that you're going to have an influence that is going to help shape the future. Why do we teach sustainability on college campuses? It's probably not shocking to you that oftentimes the most change occurs from those areas where students are free to learn, where they are free to express themselves, and that may be through demonstrations, it may be through various types of media, writing, art, that sort of thing. We also see that campuses in general are going to be more committed to sustainability because of the principle of the matter, right? So our SUNY chancellor, Christina Johnson, has put a lot of money and a lot of requirements for SUNY campuses to, basically get their act together and get onto renewable energy. So campuses are this sort of hotbed of change. And while I've been at CCC 20 years and I really thought nothing was ever going to change, 2 years ago, things started to change. So we can talk about that in our last module. You might have noticed some of those changes while you were on campus this year if you are a student on our main campus. But take a look at all the things that campuses are doing. First thing you're doing, and we have this at the college, what is our college's ecological footprint? Through this course and through some of our other non-major science courses, and even my environmental science course, students are calculating their ecological footprints and they're trying to take steps to reduce those ecological footprints. As a campus, we're trying to do the same thing. So here's lots of sustainable solutions, things you already know about. We have a recycling program. It's going to be improving. You see, promote efficient transportation options. So that means carpooling. That means, how about living on campus? That means maybe living closer to the college as opposed to driving 45 minutes to an hour every day. That includes efficient bus schedules and so on. You can take a look at planting trees, restoring native plants. We do that. We have a garden. We do that. Working on more sustainable dining halls. Working on a more sustainable residential hall. That one's a little bit trickier. Improving energy efficient and water conservation, doing that. Reducing greenhouse emissions, yes, through all those things above, we do that. And investing in renewable energy. And so big news is that within the next year or so, we should have a pretty large solar array on campus. So here's some students participating on their campuses. All right, moving on, and you can stop this video at any time if you've had enough for now. This is the video launch for what we're doing this first week, Module 1. So now we get into economics, policy, and sustainable development. So economics is tricky. So we follow neoclassical economics to the most point, to a large degree. And if you take a look at those assumptions, and you need to know these assumptions, and you'll discuss these with your team in class, but there's some assumptions that just don't make a lot of sense. One of those, resources are replaceable. Depends on how you define the resource. But what it implies is that once a resource is used up, we can replace it. And generally speaking, resources are infinite, which means, oh, well, you know, we can just come up with a different resource, a different resource, and a different resource. So it's implied that there's an infinite amount of resources when we know that's not to be the case. It says all costs and benefits are internal. That's just between the people in the interaction, in the economic interaction. And we know that's not to be the case. So depending on, how about cell phone, depending on, you know, where did all the parts and pieces and components and even metals that come from that's in my phone? Years ago, they were mining in Africa for rare metals for our phones. So this says all costs and benefits are internal. If we were in Africa creating civil war so that we can extract a rare mineral that we need for our cell phones, no, all the costs and benefits are not internal. You never probably imagine that by you buying that, you might be supporting some social and environmental injustice. The third point, we should discount the future. So we don't really think about the value of the future. So whatever we're doing now is the most important when we think about neoclassical economics. So the current situation we're in with this complete addiction to fossil fuels completely discounted the future. So we've known since late 1970s, 1980, I believe it was, that carbon dioxide concentrations were increasing. Okay, now we're at the year 2020, 30 years later, 40 years later. And so no, not even considering what might be the future risks, the future costs of our current usage of fossil fuels. The last point, all growth is good. So economic growth, and you hear this all the time, economy, economy, economy. And for some people, it's really their trigger. Woo, when the economy is good, that must mean that my life is going to be good, that I'm going to make more money, that I'm going to have more money to take care of my children and afford health insurance and maybe buy a new car that gets better gas mileage or safer or something like that. So all growth is good as a concept that's got us a little bit addicted to consumption. So something to think about. So here's just a couple of slides. Let me just look ahead and see if we need to talk about all these. I can certainly just post these slides. If you want to review some material on them, then you can see that. I think we'll go ahead and move to this slide. So here's an idea. All the resources that you need to go about your day came from somewhere, okay? For some of those things, we can hardly even imagine what they are. For example, the metabolic process called photosynthesis. Who is sitting around thanking plants for the fact that you may have a cotton t-shirt on, or that you've got paper to write on, like, or coffee in your cup? Like, who is like really going around thinking about photosynthesis? But in fact, it is a non-market value. We don't put a price tag on photosynthesis. It just happens. So the question becomes, what types of non-market values do we get that doesn't really have any economic value? So that means, well, how do we protect it? Let me see if I can magnify this. It's a little bit small. Let's see, we'll do it again and again. Okay. So here are some examples of some, in particular, non-market values in the strict sense. The use value, the worth of something we use directly. So, Big Rock. I think that's El Capitan. I could be wrong. But when you think about climbers, thinking about opportunities to go out there and use something. And it could be certainly Seneca Lake for fishing or for boating or skiing, things like that. B, what about existence value? The worth of knowing that something exists, even if we never experience it ourselves. This was a hard one to project on people who just don't give value to things too much outside of humans. C, option value, the worth of something we might use later. So giving it value because it might be useful later, even though we might not use it right now. D, aesthetic value. I love this one. Just to appreciate the beauty of something. And so how many of us have been somewhere absolutely dropping beautiful? Maybe it was Yosemite, Sequoia, Joshua Tree. Maybe it's the Chesapeake Bay. Maybe it's your local Finger Lake. I don't know. Maybe it's wherever you go to a deer stand. And there's something about that place that's so beautiful to you. And it has this sort of emotional appeal or draw. Maybe you've been there throughout your lifetime. So aesthetic value, a non-market value. E, scientific value, the worth of something for research. F, educational value. And then we have G, cultural value. So these are all things that we don't even give a price tag to, that we don't even include in our markets. Now, I mentioned photosynthesis. Natural cycles are vital to our existence, but markets impose no penalties when we disturb them. So we take a look at the next figure, then we start to see the value of the world's ecosystem services. Okay? Ecosystem services, so that includes photosynthesis. So they say that there's about, the Earth's economic value of just 17 ecosystem services each year equals 143 trillion. And that's using the value of $1 in 2014. So certainly we've had an inflation since then. And we're going to get into gross domestic product a little bit in the next slide. So what you're going to see is regulating climate. That's just this thing that happens. Are we in control of it? No. Are we contributing to the change in climate? Absolutely. Cycling of nutrients. So how about just the fact that things rot? What if rotting and decomposition just stopped? Can you imagine like all the organic matter that would just build up? So here we go. They say that recycling nutrients, so decomposition and releasing those nutrients is worth $11.1 trillion. Forming soil, worth $1 trillion. Regulating water flow, believe that's, I can't see it very well. Almost $2 trillion. Storing water supplies in clouds and in snow accumulation and mountaintops, worth $2 million. So, we start noticing some of these things when they're compromised. Erosion is worth $16 trillion. If you've worked in landscaping or excavation, or even some building like industrial parks and things like that, then you know that we have to make sure that water runs off roadways and parking lots and even around your house in such a way so that it doesn't contribute to erosion. But the fact that the earth does this naturally is worth $16 trillion to humans. But do you see this anywhere in anybody's budget? Absolutely not. What you do see is the costs that occur when we have problems with flooding. Right? Insurance companies have to pay homeowners or companies if there's flooding. But we're not thinking about putting money into preserving that service that's provided by the environment for free. All right, gross domestic product. If you haven't had an economics class or haven't in a while, you might remember that's the monetary value of the final goods and services produced each year. And we use it to basically assess how well a nation's doing. And so you're going to see, as I just mentioned, that it fails to take into account non-market values. It just doesn't think about those things. And it includes desirable and undesirable activity. So it says gross domestic product can rise as a result of crime, war, pollution, and natural disasters. In fact, when we went to war with Iraq, our gross domestic product increased as we increased on the number of people in the military, and as we were spending money cleaning up pipelines in Iraq so that we could reestablish the global market of petroleum. So kind of unfortunate that big devastating events like that can affect gross domestic product. What about hurricanes? Absolutely. With all the destruction and terror that comes from massive devastation from hurricanes, comes with it FEMA, and comes with it cleanups, and comes with it rebuilding. And that means construction, it means jobs, and so on and so forth. All right, so some folks suggest that we take a look at GPI, the Genuine Progress Indicator. So these are indicators that distinguish between desirable and undesirable economic activity. And it includes conventional economic activity plus those positive non-monetary contributions. So it might include, as I say in the slide, volunteering and parenting, but also is going to take into negative impacts such as crime and pollution. So we subtract any benefits from gross domestic product. So what you see on the left in our figure here, the gross domestic product bar represents about $7.6 trillion. And then we get these benefits that are ignored. And we can add another 4.7 trillion. But when we take that total value, which is just over $12 trillion, and now you're going to break it down into truly progress indicator, so how much progress we're making for our buck, so to speak, we have taken out the environmental costs, the social costs, and the economic costs. So now this is a better indicator of how we're doing economically, because we're not just adding war and pollution and hurricane cleanups and social issues into benefits when that truly is not necessarily a benefit. So when we think about making decisions, we want to think about what we call the triple bottom line of sustainability. So in making choices for a company, or making choices for the nation, or making choices at a school, we want to think about the three components of sustainable development. So we have the environment, we have society or social goals, and we have economy or economic goals. So we're thinking about the environment, society, and economics. And this is showing us kind of this Venn diagram where these three goals overlap. And we're thinking truly about, again, meeting the needs of the present without compromising the needs of the future. Then we can identify those goals when it's good for society, it's good for the environment, and it's good for economic advancement. So you want to be thinking about this. You will have an activity in the future that's going to have you thinking about these goals, and you and your team will design a product that includes those goals. All right, the last part that I'm going to cover in this intro module is going to be biodiversity. So when you think about all the different species on the planet, you're probably thinking, oh, right, that's biodiversity, all variety of life on Earth. Turns out that ecologists like to dig a little deeper. So we're not just going to think about all different species on the planet, but we want to think about the population sizes of those different species, and we also want to think about the diversity of the ecosystem, so those areas where those species are going to live. So we've got different levels of diversity. What's good for species diversity is obviously high and healthy ecosystems, as well as having populations that make up those individual species that are numerous enough to maintain genetic diversity. So one of the things that happens when species go extinct is that we first can just recognize that their populations are lowering. In some species, that happens gradually over time. With something like a passenger pigeon, the populations the lower populations was not noticeable and critical to most humans. And because a passenger pigeon, they are flocking birds, and they like to roost in very large numbers, that once those roosts got too small, it caused a collapse. So sometimes waiting for the populations to get to some critical low amount that we think is okay, it's already too late. So thinking about genetic diversity of the individuals of a population is crucial to maintaining our biodiversity. Okay, so scientists have named and described 1.8 million species on the planet. What this means is that someone has gone out, they found what they thought was a new organism, and then they studied the heck out of it. You've got to determine beyond a reasonable doubt that this species truly is different than all other species that have been discovered. You have to discover their life cycles, determine how they reproduce, if they're microscopic, how do they move around, how do they, are they asexual or sexual, all sorts of subcellular microscopy stuff, like organelles. If you're something large and you discover a new primate, for example, then you want to determine what are their mates? Do their mates look the same? Do they look different? So sometimes you have what we call sexual dimorphism, where the individuals of the species can look different. In birds, that can be very different in some species. But when we have done that exhaustive work, we can say, okay, we have named 1.8 million species. But when scientists go into what we call hotspots on the planet, those areas that are known because of some biome features, known to be areas with high biodiversity, when scientists go in there and they do inventories, massive inventories, they can basically start to calculate how many of these species were named and how many of these species are not named. And then you can start to get an idea of how many species are out there that we haven't even discovered. And I know that seems really esoteric, but it is a thing, because right now, as we see huge threats to biodiversity, we are worried about the continuing loss of species. So we'll talk about some threats to biodiversity. You'll have an activity this week. But what we see is that we have grossly underestimated the number of species on the planet. Most scientists will agree something like 1 million species on the planet, but it's been as low as 3 and up to 100 million species are thought to be on the planet. So 14 million is another one. I think I said 10, I misspoke. 14 million species is the widely accepted number. So think about bacteria. Right now there's this these huge research labs that are studying just gut bacteria. There are so many bacteria that we don't even know. Like, if you want to discover new species, research bacteria. My background is in slime molds, and it was pretty easy to find new slime molds. My name is associated with one slime mold, which is kind of cool. But you can see that there's tons of things out there that are not known to science, and it's usually microorganisms, so those small little things. Why do we care about biodiversity? I don't know if any of you eat kind of what I call fringy food. So like chia seeds, acai berries, just some things that you're just like, what is that? We have brought so many new kinds of foods to the supermarket, but the reason why we can do this is because we've maintained biodiversity of a variety of kinds of foods. So industrialized agriculture has narrowed our diet to 15 crops in 8 livestock species. So think corn, potatoes, oranges, like the typical American diet. Wild and rare species, though, can improve food security. So maybe you've heard of amaranth. Amaranth is a substitute, if you will, for grains. So that might be something that we're eating if we're not able to grow rice as well as we'd like to grow it. It says crop ancestors, so some species like heirloom tomatoes have in them a huge genetic diversity that we can go back and capitalize on, so we can add more biodiversity and add more genetic diversity to our food crops. So why do we care about biodiversity? One reason, food security. I don't know how many of you have been to Mexico, But there's this crazy little loud, obnoxious bird, which kind of reminds you of a chicken. It's called a chacalaca, and they're quite annoying. So if you go to a resort in Mexico, you're probably going to have some chacalacas at your door because, you know, there's just food available. And if they planted it in native plants, then, of course, those chacalacas are going to be there. They'll wake you up in the morning going, chacalaca, laka, 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 laka. So, going to go to Mexico on your honeymoon? Just no. You might get a wake-up call really early in the morning. Here's amaranth. So you see it's a grain and early vegetable. You can use a livestock feed. It's drought-resistant. You might want to eat maca root. So it's a cold-resistant root vegetable resembling radish. It has a distinctive flavor. Baruti palm. These also grow very pervasively in Mexico. A couple other animals that we might end up eating if we're not able to continue growing the things that we're, or raising the things that we're raising today for food. Now, the reason why we care about biodiversity is because of new drugs and medicines. So oftentimes our discovery of medicines come from finding biochemical properties, usually secondary metabolites in plants. So studying not only the plants that we know now, but studying those things that aren't even known to science could be sources of new medications. So it says wild species produce up to $150 billion per year of drugs that save thousands of lives. Here's some other ways that biodiversity provides, going back to ecosystem services. A big one here, pollination. I have so many TED Talks I'd like to show you all this semester. I've narrowed it down to 5, but I just, in having this conversation with you in this lecture, thought of 2 more. But thinking about what does our grocery store look like if we have reduced amount of pollinators, particularly bees, pollinating our plants. I see that something like 60%, 65% of what you would see in the produce department would be gone. Okay, our bee populations are being threatened. Why are they threatened? A good deal of it comes from the use of insecticides. Not a big no-brainer type thing, but turns out that was kind of a no-brainer type thing. We've also used a tremendous amount of weed killers, if you will, that kill the plants that bees like to eat. So there's a couple of things. So hopefully you're taking a look at the figure. So moving along. Biodiversity is really important to maintaining what we call resilience of ecosystems. So you might imagine the ecosystem like a fabric. And if you ever looked at fabric really closely, you've got these interwoven threads, okay? And they usually, it depends on the weave, but just in a really simple weave, you've got them going in 2 different directions. So that biodiversity is forming connections in those fibers, okay? And so what happens is as we lose a species, or even as a population declines, then it's going to affect anything that eats it and the things that it might eat, okay? So if I'm a plant, though, it could just be anything that eats it. So once we start to lose biodiversity, we decline populations, we lose species, then that integrity of that fabric, it's kind of like if you have an old concert t-shirt and you've had it a really long time, and you wear it and wear it and wear it, and after every time you wear it, you throw it in the wash, and you've had it for 10 years, it starts to get loose and worn out. Maybe it has holes in it. So as we lose biodiversity, it's going to weaken that fabric of the ecosystem. And when it does that, it's going to make prone to collapse. It's hard to predict the effects of biodiversity loss, but we know that there's these thing called keystone species, which are often top predators. So when we lose a keystone species, which you'll learn about this week, one of those being the gray wolf in the Yellowstone National Park, when you lose a top level predator, it causes a trophic cascade. So it causes literally an avalanche of effects on the entire ecosystem. We also know that those things that are called ecosystem engineers. So we know ants, earthworms, beavers are ecosystem engineers. So as we see those being lost, then we can also see major changes occur. Just a couple more slides and we'll be finished with this week's lecture. So there's a movement, kind of of an old movement, actually, 20 years in the making, but it's called ecotourism. So some countries are realizing that while they could grow, for example, tropical countries could grow more sugarcane, pineapple, tropical fruits and such, that there's more benefit to actually preserving their ecosystems rather than maybe clear cutting it or selectively harvesting and planting crops. Instead, what they like to do is promote individuals coming to that country to experience nature. So it's called ecotourism. Costa Rica has definitely been a model for that. We visited Costa Rica 3 or 4 years ago, and it was a phenomenal experience. But they're seeing more value in tourism rather than just selling resources. Australia is a little bit of a sad situation with the Great Barrier Reef. The Great Barrier Reef, I believe several years ago, was pronounced dead. But their ecotourism started out not being very sustainable. And as a result, tourists that didn't feel comfortable snorkeling and maybe didn't understand the languages that were being spoken on the tours often got scared swimming or snorkeling along the Great Barrier Reef and would stand on the reef. Plus you have these very large, almost ferry-sized ships taking tourists out to the Great Barrier Reef. And so that caused a lot of damage. I've also been there. That was the year 2003. U.S. national parks. One concern that we have about national parks is ensuring that the restrictions are in place based on being a national park as opposed to being a Bureau of Land Management or some other category of land managed by the U.S. But our national parks create a great opportunity for some of those non-market values, use value and aesthetic value and so on. And a great deal of money comes in through national parks. So right now we see a lot of national parks and even zoos and museums are really hurting financially because during 2020 Corona time, we're not able to visit places. We can do virtual tours though. So anyway, moving on, last couple slides, I promise. One thing that you might ponder while you're taking this course is, what is the value of your connection with nature? So where's your favorite spot? Is there a spot that you've visited maybe just once? Or maybe it's a spot that you go to often since your childhood? But thinking about, what is our bond with nature? So there's this term coined by conservation biologist E.O. Wilson. It's called biophilia. So humans love nature and have an emotional bond with other living things. And sometimes we just see this just, watching a documentary. You find yourself kind of getting the feels, when you're hearing something or seeing something. But you might reflect on your relationship with nature as you're going through the course. Now, some people might suffer from what they call NDD, nature deficit disorder. This was coined in 2005 by Richard Louv. Basically, the alienation from biodiversity in nature damages childhood development. So when children don't have enough time to be out in nature, smelling the fresh air, picking the dandelions, blowing on the dandelion dry fruits and making them blow everywhere, but getting people connected with nature. So there's this very awesome program called, now I can't remember. Well, there's Outward Bound. You might have heard of that one. There's a big hiking institute in Arizona, Philmont, and part of part of those programs are to get teenagers out into nature and to experience something outside of the four walls, the screens, the technology, and really trying to foster some connection with something outside of themselves. So that might be something that's interesting to you. All right, just seeing where we are. Okay, I think we'll finish up on this idea of biodiversity hotspots. So biodiversity hotspots have been recognized by major international conservation organizations like Conservation International. Thinking about geographic regions and taking a look at habitat loss. Those areas that have lost already 70% of its habitat as a result of human impacts is often targeted as a hotspot. The other thing is that area must have at least, it says, 1,500 endemic plant species. Okay, 1,500 endemic plant species. So endemic means it's only found there on the planet. So if it's a plant native to Puerto Rico, you're not going to find it in Australia. You're not going to find it in India. You're not going to find it in Iraq. So areas that have huge threats to habitat loss, as well as 1,500 endemic plant species or more. This is a figure. It's going to be similar to one that you see in our activity that shows us of some hot spots that are recognized by Conservation International around the Earth. It's no accident that many of these areas are in the tropical bands, so between the Tropic of Cancer and Capricorn, extending just a little bit further north and south. So this should set you up well for Module 1, TED Talk, and team activities. So as always, let me know whatever questions you have over the content.